So for this problem, we are tasked to solve for the angle y, angle x, and the length of the cable. So to do so, first we draw the free body diagram of the supports. Here we have AX and AY. For D, we have components dx and dy. Now since we don't know for the value of y nor the value of x, but we do know that this is 35 degrees, we can solve for D for this length of the cable and its horizontal and vertical distance. Since we know that this is 7 meters, we can solve for this vertical component by using the tangent function. So this is tangent 35 is equal to the, let's call this let's call this z equals to opposite z over adjacent equal to 7 meters. So z is equal to 7 tangent 35. That is equal to 4.9. Okay, now that we have the distance z, we can proceed solving for the tensions of the cable by cutting this section here. By doing so, we expose tension CD on this left side. Let me erase this first. So here we expose tension CD by cutting on this section. And then drawing its component, here we have the vertical and horizontal component of CD that is equal to tension CD sine of 35 degrees. And for this side here, this is tension CD times cosine of 35 degrees. Now to solve for tension CD, what we can do is take summation force at, taking moments at point A so that we only expose tension CD. We can create a expression of one variable that is tension CD. Doing so, summation moment at A equal to 0, and considering counterclockwise to be positive, here we have negative 16 because it's going the clockwise direction times 6 meters minus 20 kilonewton times 17 plus tension CD sine of 35 degrees times a moment arm distance of 17 meters, and then plus tension CD cosine of 35 degrees times the moment arm distance of, we have solved 7 plus 4.9, that is equal to 11.9, equal to 0. And we can solve for tension CD. Here we have CD is equal to 22.36 kilonewtons. Okay, so now that we have tension CD, we can consider force. We can consider point D by cutting on this segment, and then considering the right side. Here we expose tension CD that is going to the bottom left. So by drawing a free body diagram, we have dx, dy, and the tension CD, and its angle of 35 degrees. So by taking summation force horizontal, we can solve for dx, that is just equal to dcd cosine of 35 degrees. Therefore, ddx is equal to 18.32 kilonewtons. And for dy, we take summation force vertical equal to 0. So dy is just equal to dcd sine of 35 degrees. That's equal to 12.83 kilonewtons. Now that we have the x and dy, I believe we can solve for the support reaction AX and AY by taking summation force horizontal equal to 0. So we have negative AX plus dx of 18.32 kilonewtons equal to 0. So AX is basically equal to 18.32. And by taking summation force vertical equal to 0, we can solve for AY. that is AY minus 16 minus 20 plus DY of 12.83 equal to 0. And here we get AY. That is equal to 23.17 kilonewtons. Now we have AX and AY. We're going to solve for the value of angle Y by considering point A. So at point A, we have force AY, AX, and tension AB. This is the angle that we are interested in solving. By taking summation force horizontal equal to 0, we have tension AB cosine of Y minus AX is equal to 18.32 kilonewtons equal to 0. So tension AB cos Y must equal to 18.32 kilonewtons. And taking summation force vertical equal to 0, we have tension AB sine of, this is negative, tension AB sine of Y plus AY, that is equal to 23.17 kilonewton must equal to 0, or tension AB sine Y is equal to 23.17 kilonewtons. Now we have two equations with two unknowns. To solve for the angle Y, we divide equation 1 with equation 2. So DAB cancels. What is left is cosine Y over sine Y is equal to, to make this simpler, why not we divide equation 2, that is DAB sine Y, with equation 1, DAB cos Y. So we will get sine Y over cosine Y is equal to 23.17 divided by 18.32. And sine Y over cosine Y, that is just basically tangent of Y. So to solve for Y, we get the arctangent of 23.17 divided by 18.32. So Y is equal to arctan 23.17 divided by 18.32. That is 51.67 degrees. Now that we have the value for angle Y, we can solve for tension AB by considering equation 1 or equation 2. So let's say equation 1. So tension AB times cosine of 51.67 degrees equal to 18.32 kilonewtons. So tension AB is equal to 29.54 kilonewtons. So let me erase this. Now that we have tension AB, we can now proceed on solving for angle X by considering point B. So at point B, we have a 16 kilonewton force downwards. We have tension AB with an angle of 29.54 kilonewtons. 51.67. degrees. And we have a tension force BC that is acting in the direction of x degrees. Now that we have tension AB that is equal to 29.54, we can solve for the value of TBC and x by doing summation force vertical and horizontal. So taking summation force x equal to 0, we have TBC cosine of x, that is minus TAB 29.54 cosine of 51.67 degrees equal to 0. Manipulating this equation, we have TBC is equal to 29.54 cosine 51.67 degrees divided by cosine x. And then we do summation force vertical. So here we have DAB, that is 29.54 kilonewtons times sine of 51.67 degrees minus 16 minus TBC sine of x equal to 0. From the first equation, we have TBC in terms of cos x, we plug in this value into the second equation so that we can solve for the value of x. That is 29.54 sine 51.67 degrees minus 16 minus TBC, that is 29.54 cosine of 51.67 degrees divided by cosine x times sine x is equal to 0, and we can solve for x. Here, we have x is equal to 21.38 degrees. Now that we have the values for x and y, I believe we can now solve for the problem number 3, that is the total length of the cable. Now, considering this triangle here, we know this angle is y, this angle is 6. We can determine this length AB by using the cosine function. That is, cosine of y is equal to 6 over length of AB. So AB is equal to 6 divided by cosine of y, that is 51.67 degrees. And for length BC, here we have the length of 11 meters. And this one here has a angle of 21.38. We can again use the cosine function. So this is cosine x equal to adjacent 11 divided by hypotenuse BC. So the length of BC is equal to 11 divided by cos 21.38 degrees. And to solve for the length of CD, we do the same thing. Cosine of 35 degrees, that is equal to the adjacent length, that is 7 divided by CD. So CD is equal to 7 divided by cosine of 35 degrees. Now let's solve for the values of this lengths. For AB, that is 6 divided by cos 51.67 degrees. That is 9.67. And for BC, that is 11 divided by cosine of 21.38. Which is equal to 11.81. And for CD, this is equal to 7 divided by cosine of 35 degrees, which is equal to 8.55. Therefore, the overall length of the cable is just basically the sum of AB, BC, and CD. This is equal to 30.03 meters.